Okay, nobody dropped. That's great. Good news. I didn't scare you away, or I made the class sound too easy the first day, which is good. No, I'm just kidding. Welcome to Mobile Sensing Learning. This is Lecture 2. I'm going to incorporate all of these slides probably into Lecture 2 and 3. So that's why I've titled it that way. And we'll see how far we get today and how much we're actually going to cover with model view controllers, etc. So I want to get some logistics, which we'll do every day. So class logistics, the lab time for the class that we decided last time was going to be Wednesdays from 5 to 7. It is not a required lab. It is simply a time that your teams can come in and work on the Mac Minis, and I will be here, right? If there's someone here at 5 o'clock and you guys stay till 7, I will be here the whole time for questions, whatever you want to do, and bounce off me, okay? So I'll be here for the entire lab section. The best office hours, it turned out that the best office hours based on some emails and things with people are going to be, I'm going to have 2 sessions. So on Wednesday, 1 to 3, Friday, 1 to 3. Okay, and that's kind of the best of both worlds. And that way, if you do have some questions, you finish your app early and you don't want to come to me as a team on Wednesday and say, hey, we're turning this in. That's fine. You should be able to have time and do that. My office is right in there. I'm right behind the mailboxes when you walk into the main office of CSE. Okay, I'm in 451. Teams. Who is on a team? Who's not on a team? One person? Is that it? Yeah? Okay. So if you want, or if there's people that aren't here yet, what you can do is go over to Blackboard. And if you're on a team right now, go ahead and tell me that you're on a team, who's on the team, in kind of the, up right here, the format that I have on Blackboard. And this is really just so that I know who all is on your team and what you guys are planning. This also will be a good place to start if there is anyone that isn't on a team, or somebody that didn't raise their hand that isn't on a team. You can also post up here and say, hey, I'm looking for a team to be on. Or get with some of the teams that post here and ask if you can be on their team. Right? So if you don't know anybody, email them. It's the best way to do. Right? Okay, so try and do that by Wednesday, by lab section on Wednesday. Have your teams decided, right? Teams of 2 to 3. Okay. Video, access to the video. Some people have already found it. You can go on Blackboard and get access to the video. So I'm doing a screen recording right here, so all of that is there. And that's why you can see me on the slides right now, because I'm doing a screen recording. So has anybody not gotten access to the videos that wanted to? It's a big file. It's about 1 gigabyte each, but you can stream it down from Blackboard, or you can download the whole thing. The only thing is just don't post it publicly, because SMU owns this. Yeah? Good? Nothing? All right. So do you guys have access to the minis and phones? Yes, you do. So I just set everything up, and the way that I set everything up is if you go in here to the locker, I'm going to go ahead and just kind of pull this through. So each of these lockers has a Mac Mini in it and a development phone. So they're each like in little cubicles on every single little floor that's there. So you'll find 8 of the Mac Minis and 8 iPhone 5Ss that you can get access to. That Mini and that iPhone are ready to go for development. So you should just kick on XCode, and the university really hasn't gotten back to me yet on getting our developer program kind of set up and running through legal. So I just set it up with mine. So it's good to go for right now. Once I get the university developer program set up, then I'll have everything kind of ready to go. If you have a phone that you want to develop on, I can go ahead and give you a kind of provisioning profile for that phone and my developer account to use in the interim before we get the university thing set up. But everything that we have to do here for basically the first 2 weeks, you can do with the emulator. So if you have access to Xcode, you can run it on the emulator and be able to do just fine. However, be aware that you probably need to prototype it on the device to make sure that everything runs. Yeah? Questions about that? No. If you get into Xcode and it starts complaining about a certificate or something, do not let Xcode manage that certificate, because it's my certificate and it'll break everything else. It'll revoke basically my my certificate that I have installed on every single machine, and nobody will be able to develop on the phones. We'll have to redo the whole thing. Okay. So until we get something set up, that's the best we have. Yeah. Good. Happiness. All right. I don't know if everyone has access to the room yet. If you don't, I will solve that probably tomorrow with someone in the office, and make sure that you have card swipe access into this room so that you can get in anytime, day or night. I have no idea when you guys work and when you find it's time to work. Since you're computer science students, a lot of you, it's probably the middle of the night is my experience with you guys. You guys don't wake up early. Have you ever collaborated with someone in the medical world? They get up at the crack of dawn, right? And then the computer science students, they want to do their meetings at like 6 p.m., right? And the medical students are like, oh, how about 4:30 or 5 in the morning? Like, what? No? Anyway. So, oh, I did forget to use the Mini and the phone that are together in the same cubicle. So you'll see the phone, so there's a Mac Mini in there, and this name will be like CH484 Mac 7, right? The phone that's on top of its name is CH484 Mac 7's iPhone, okay? So you can associate those really, really easily. If you haven't already, you can set up a free account on developer.apple.com. That will give you access to a lot of different resources. Okay, when I started out with iOS coding, I used a lot of the development stuff that's on there. They have videos from all of the WWDC conferences. They have sample code. They have slides that you can get access to. It's really a great resource. Okay, so if you do have questions or you want to work on things, especially things that we don't cover in class, that is an excellent resource to have. And a lot of examples and code snippets are up there. And for the most part, they have a lot of iOS 7 stuff too. But you'll find all sorts of deprecated stuff too, from like iOS 5 and 6 and things that are not actually working anymore. But you can still run the code for the most part, even though it's deprecated. Yeah? Okay. So assignment 1 is up. I'm hoping that everybody had time enough to go onto the website and take a look at it, at least what it is. If not, I'm going to tell you a little bit about what I want you to do. So this is going to be due Friday, February 7th, so not this Friday, next Friday. You've got basically a full 2 weeks here, or a full 2 weeks from last Friday. Okay? So don't freak out. You've got plenty of time. Everything in bold is something that we're going to go through for the next 2 lectures. Anything that's not in bold, I am not going to explicitly go over. I'm going to assume that you can figure out or ask me a question about. Okay? So the assignment 1, I want you to use a UI table view as your main view controller, and we'll talk about what that is. But you'll use a UI table view to basically segue into a bunch of different other views. Okay? Your app doesn't have to have any specific functionality to it. This is more, hey, I know how to use iOS, and I know how to use all of the little widgets and labels and objects that I can add into a storyboard on there. I also know how to use the different view controllers. So one of the view controllers that you'll have to use is the navigation controller. You'll also have to use, obviously you have to use the UI table view controller because that's going to be your main view controller that segues into everything else in the app. And I also want you to use a UI page view. Okay, and we're going to go over all of those. Maybe we'll get to some today. We'll at least get to some of it today. Maybe not all of it. So you'll also have to use automatic layout, and that's to make your life a lot easier, because the first thing I'm going to do when I get your app is I'm going to take a look at it, I'm going to transition it into landscape mode, and it has to work in both, okay? And so anything that you add, so you add a button or you add a label into this view, it has to do something, right? So when I press that button, it has to visually change the interface in some way. It could be updating a label, it could be changing a color, whatever. It could be, enabling or disabling other buttons or labels that are on there. So you'll have to do that. You'll have to use auto layout for that. You will also have to programmatically create buttons, sliders, and labels inside the interface. Those also have to work in landscape and portrait mode. Okay, so today, we'll probably get to that today. I want you to set up layout constraints in code, right? this is something that's really, really useful when you're loading a view and you don't know exactly what content you want to have on that view. You want it to be a little bit dynamic. So you're going to add different buttons or sliders or labels on there programmatically based on something else that happened maybe earlier on in the application. Okay? Or there's control mechanisms for like some filtering on an image thing that you want to do, which we'll do later on in one of the labs. And you don't know what the parameters of that filter are until the user tells you what filters they want to use, right? And so there'll be a bunch of slider controls that you want to control all the parameters for something. Okay? What else? What else? Any questions on assignment 1? Nothing yet. Yeah, there's probably nothing yet because you haven't really looked at it. Don't wait until the day before. I will know. I will know and I will have no sympathy for you. I have a little bit of sympathy. All right. So the agenda for today, let's cover model view controllers. If you know this stuff, that's fine. Sit back, relax, veg out for a little while. We'll get to some stuff that you don't know, I promise. We're going to go over the storyboard. We're going to create our own UI view controller and subclass it. We're going to go through a bunch of different outlets and auto layout and auto layout programmatically. I'll go over probably timers today, I think. And then when we have time, we're going to go over more view controllers that are out, so how to deal with all of the different UI view controllers that are there. And through this whole kind of lecture, we're going to do a giant demo within XCode, and I'm basically going to be teaching you ObjectiveC by demonstration. So if I write something down on XCode and you're like, what is that? I've never seen that before. Ask me a question, or raise your hand, or stop me, right? So, because inevitably I'm going to try and explain everything that I'm doing, but inevitably I'm going to miss something. Just raise your hand and be like, what did you just do right there? What is that? I don't know what that means. Okay? Good. And just yell out. Even if you don't raise your hand, just yell at me. Okay? This is the one class you get to yell at me. Not too loud. All right. A model view controller. Okay. So it's basically 3 different systems. All right? This is an architecture, and this is an architecture that iOS is built upon. So you're going to have this thing called a controller, okay? And the controller controls the view. It has all of the logic for interpreting whatever your model is and transferring it to the view so that your user can interact with it, okay? That is the entire purpose of the view controller, okay? It syncs up the view with the model. Your model can be just about anything, okay? Your model can be a set of classes that you have. It can be just the underlying logic for a game or whatever your application does. It could be a database. It could be other model view controllers, okay? And the way that your controller and your model are going to talk with one another is usually your controller has a direct reference to your model, okay? So what I mean by that is, let's say I've got some code up here. I've got this little thing right here, which is my model, okay? And if I'm in my controller right here, I have a direct reference to my model. I'm going to send it the message, hey, get a number out of the model. So this is a phone book model or phone number model, where basically I'm asking for a number. So I have this class called phone number, and I set it equal to what comes back from my model, okay? And then I'm going to update some phone number label, the text of it, to the number for my model, okay? That's all I'm trying to show you there is you have a direct reference to your model. Your model doesn't talk directly really to anyone, okay? Your model, the only reason your model needs to talk to someone is if it changes, right? So let's say you've got, let's say it's an underlying database, okay? You've got some database that you're querying and you're grabbing stuff from so that you can present it to the user. If your database changes, you want to send out what's called a notification, okay? And so it's going to send out a notification, and anyone that is listening or has assigned themselves as an observer for that notification is going to get that message. So if you're a view controller, you can get that message and change the view, right, based on this underlying model that changed, right? So we also need to know what the view is. The view is basically your interface. It is between your view controller and your user. It has the gestures, everything that the user interacts with happens in the view, and that's going to get interpreted by the view controller. So the way that the view interprets everything back to the controller is, first of all, there's this thing called outlets, right? So the view controller is going to have some direct access to some of the outlets that are in the view, which is basically just kind of a reference so that it can go in and grab all of the different things. So if you lay down a button or you lay down a UI text view, it has an outlet to that, and you give that outlet a specific name so that it can get reference to any outlet that's there. It's very, very typical. If you had a bunch of text fields, let's carry on with the phone book example. You would have, let's say, 3 UI text fields, which are first name, last name, and phone number. All of those are outlets that would be declared inside of your view controller. And we'll go over this so that this is concrete too. The other way that the view can communicate back with the controller is through something called, let's say, a delegate protocol. Right, so in this, let's say you have some class called your main view controller. You can say, I am the UI text field delegate. And what that means is that I am going to implement a protocol. And that protocol, I am setting myself as the delegate to receive messages that would normally go to a UI text view. Right, so basically what that means is that any function that would normally get sent to the UI text view is now going to get sent to the UI text view delegate. So my main view controller could receive this thing called text field should return, and it's going to have a reference to the text field that sent it. Okay, so when you set yourself as a delegate, you're basically saying I am going to implement the protocol that is necessary for a UI text field delegate or a UI table view, right? There's a bunch of different protocols and things. Does anybody know why we have protocols? Yeah, go for it. What question?
What is the hashtag problem?
Oh, you can, okay, so in your code, you can put any of these pragmas. So I can put a pragma, mark, UI text field delegates, right? And basically what that's going to allow me to do is in Xcode, it's going to organize, so when I want to navigate to something, it'll basically put in these bolded outline things so that I know where all my delegates are, or I know where all my properties are, or my functions, or however I want to kind of define my own hierarchy, right?
But it's like a comment.
It's a comment. It's a comment. Now a comment is still //, right? That is a comment. This is just a special pragma, right? Good? Good, and we'll go over a little bit of that too. So basically, you're setting yourself as the delegate to receive those notifications. You can also be the data source for a specific view, right? So for the UI table view, it needs a data source, and a data source is something that it knows to ask questions to, and it will return some specified things. So if you're a table view, you're going to want to know, well, how many rows do you have? How many sections do you have? And what do each of those cells look like in my table, right? And so if you are subclassing the table view controller, you will set yourself as the data source for that table, which means, okay, I'm going to implement the function get how many rows, get how many sections, or get how many rows in a section, okay? And it's basically, it's very, very similar to the protocols and delegates that there. It's just a data source is specific that you are providing data to the view. Happiness? Good? We're starting out slow, don't worry. Okay, and then you have this protocol of target action, right? So in the same way that you can assign outlets, you can assign actions to different control events that happen in the view. Very, very similar. If you've ever programmed on a mobile phone, you're kind of familiar with this already. What your view does is it says, I have this IB action, which is just tells the compiler that this is an action that's happening from a view. And I'm going to assign that from, say, when a button gets pressed, the touch up event. The touch up event is the action that's going to get sent to your model view controller so that you can do some stuff because you know that that button was pressed. Okay? Very, very similar to anything you've ever worked on. Questions about the model view controller architecture, right? We like to keep things that are supposed to be in the view. Things that are supposed to be in the controller. And this is completely this is your architecture. As the programmer, it is your job to make sure that this model view controller hierarchy stays that way. Because if you wanted to, you could just create your model in the controller, and iOS, the whole Xcode would be happy with you. That's fine. You can do that. It's just you are breaking the model view controller hierarchy that's there. Okay, so it's up to you to make sure that if you have a model, it stays in the model. Or if it's simple enough, maybe you put it in the controller. It's a judgment call. Yeah? Okay, so the next thing we're going to talk about is the life cycle of the model and the view and the controller, right? So these are functions and that are going to be called, that are set to call in iOS. And this is what you can expect to have happened or will be happening with your view during these specific calls, okay? So let's say that you have this view controller down here, which is just a table view. And what happens is anytime that you click on one of these, it's going to open up another view which displays some data about, let's say, a phone number that you clicked on, okay? So I have my table view. I've got 3 phone numbers. I don't know many people. And bam, I click on myself right there. And the first thing that happens is this new view that I'm going to transition to, it's instantiated, okay? Which means that it's basically taken out of Xcode, deserialized, and it's there. So that view now exists, okay? None of the outlets in that view are set. So all of those UI text views, those are all nothing. They point to nothing right now, okay? So I've clicked that button, it created the view, and then it's going to call this function, if I'm segueing to it, prepare for segue. Okay, so I'm segueing from one view to the next, right, which is going to slide over on my iPhone screen. And it's going to call this prepare for segue. Now, in prepare for segue, yes, this view and this class are instantiated, but none of the outlets are set. So if you do something with an outlet in the function prepare for segue, it ain't going to show up. Okay? The next things that happens are then the outlets get set. So after it calls to say, hey, did you want to do anything because you were segueing from this one view to another, you do what you need to do. Then it sets all of the outlets that are down here in the view that I have the gray box around. So these are just some UI text view outlets. Okay? After that, inside of this class, it's going to call viewDidLoad. Wow. Awesome. Because the view is loaded. Everything that is there that you would need from that view is now loaded and set and ready to go, right? So if you wanted to put my name and address here, the phone numbers, you can fill up all of those delegates after viewDidLoad is called, okay? The next thing that happens is view will appear, right? So even if it's loaded and everything's set, it has not shown that to the user yet, okay? Right? So it's going to let you do whatever it thinks you need to do, then it's going to show it to the user. So then it calls this function view will appear, which basically is letting you know that everything is loaded. This is about to be shown to the user. So anything that you need to do before the user gets shown the information, you do it right here. Okay? Most of the time, we don't use this so much because this is really waiting until the very, very end of everything else that's happening with basically your view controller. And then it's like, okay, everything that iOS that I was going to do is done. View will appear. Do whatever you need to do in there. Maybe you relied on something that I set up after viewDidLoad. Then it shows it to the user. And then it calls the function viewDidAppear. Okay, and if you wanted to do something in there, you could. Most of the time, we're going to deal with prepare for segue and viewDidLoad. For most of the time, there will be some things where we're going to want to wait till the very last minute to do something, and we'll do that in view will appear. Okay? Questions?
What would you do in view did appear?
In view did appear?
Yes.
It's tough to say. I haven't done anything recently, so I don't have anything like really kind of close in there. But can anybody think of any? Has anybody ever used the view did appear for something?
I haven't used it, but I was thinking if you call view did appear and then you set a timer from the minute that's called, and then something happens a certain amount of time after.
Yeah. So that would be good. Is if you had like a countdown or a count up for how long someone's been on a page, or you just wanted to know that, you could fire off a timer in view did appear, and you would know exactly how long something had been done there. Okay? And you could also do that in view did load, and we're talking about microseconds difference here, right? Okay? You can do, honestly, you're not supposed to do a whole lot in view did load, but this is a user interface, okay? Like in the time that it takes someone to click, you can probably do, you know, a billion things on this thing, okay? Yeah, 500 million things. Okay, so the storyboard. This is where you're going to create all of your different views that exist. And this is where you're going to tell XCode how they are subclassed and how you want to deal with them. And you're going to set different buttons and outlets and everything in the storyboard. So, when you start up Xcode, you'll get this little view controller that's right here. And then you'll have all of these little things down here, a lot like last time where we just dragged over a button and a label and we were kind of good to go, right? And we can drag anything out from over here. Okay? So, now that we know the model view controller architecture, we know all of that, we're going to do a gigantic demo. Okay, so I'm going to open up Xcode and just kind of go in, and we're going to go over the Objective-C basics. We're going to go over the storyboard basics and everything that's in there. And we're going to probably go over delegates with that before coming back to the slides. Okay? Are there any questions before we switch over to actually programming? Nope? Okay. So let's open up Xcode. So I'm going to go ahead and create a new project here. And we will call, I'm going to create a single view application. Hit next. And I'm going to call this Lecture2 Example. Okay. And company identifier, I'll just leave it as SMU. I want to do this only for the iPad, for the iPhone. And I'll go ahead and class prefix. What should we call this? We should call this something unambiguous. This is going to add, otherwise it's just going to create this generic class called ViewController. I think I want that to be, what's that? Demo ViewController. Okay, next. So we'll go ahead and put it on the desktop. Voila. Okay, so don't pay attention to any of that. There's a couple of files here called the AppDelegate, which we will mess with just a little bit today. Can everybody see that? That looks really small to me. Hold on, let me set my preferences. Class projector. Better? Okay. That also helps because the video that I'm storing, I'm doing it in 480p, which is kind of this least compression that I can do, so having bigger text may help a little bit here. You don't normally do a whole lot inside of these app delegates unless you want to be able to run and get notifications while you're in the background when the user is not there, or when you want to override some of the default application things. Okay, so we'll do that a little bit here when we want to override some of the stylistic things that are already set up on iOS 7. Questions?
When I go to like one of the files along inside and click on it, it opens up like a whole new text window. How are you going to?
Are you double clicking?
Yeah.
Stop double clicking.
Just single click.
Single click. Yes, that's good. It's a question I can answer. I feel happy. All right. You can also create tabs. So if you, I think Command T, right? So if I hit Command T, it's going to create a new tab right here. So I can go over to this. So I can go back here. These are the same things, but now if I go to like, oh, here's my view controller, I can just go back to my app delegate right here, right? So this works a lot like Safari or Chrome. Chrome did it first, so we'll say it works a lot like Chrome. All right. So let's go to our storyboard. Voila, demo view controller. And I'm going to go ahead and I will leave it up there. I'm going to make me smaller. Okay. So inside of this right here, the first thing that I want to do is kind of go over some Objective-C basics. So this is the view controller. If I click down here, that has me, you see I've selected the entire view controller, it's all blue, right? One of the biggest things, and you're going to do this, and I do this all the time, is I click on here, and I'm like, oh wait, this is a custom class, it's a UI view, it's not my view controller. That's because I've actually clicked the view. If you click down here, that's the view controller, okay? And so I can see that this is a class demo view controller, yeah? And you can get access to a bunch of different attributes of that class or what you want to do with that. This window over here is set up hierarchically, right? So everything that inherits from this, you will see over here, right? So I can see that here's ViewController and here are my options, and then I'll get to that here in a little bit. Okay, so the first thing that I want to do, let's look at my ViewController. So the first thing that happens is I've imported UIKit, right, which is basically everything in iOS uses the UIKit. Okay, so you'll notice I did not do a #include. It's import. Okay, and this is very, very similar to if you've worked with Python before. This is the same thing as the Python import. There's no such thing as a circular reference. Okay, so if you've done #include, you're working in C++, and you get all of these errors when you accidentally included something somewhere that you included something somewhere else, and now it's got a circular reference, and that doesn't exist in Objective-C. Okay, so it's just the import command. If you import something twice, it doesn't care. It just doesn't do it the second time. It's a no-op. Okay, so here's this @interface, right, which is basically telling Xcode that this is a class, and the class is demo ViewController. It inherits from UI ViewController. Okay, everything happy there? Pretty simple. Here's where things get a little different in Objective-C. Anything that you put in the .h file is public. That is your public API. That means that anybody who instantiates the demo ViewController class, they have access to everything that you put right here in that implementation. Okay, that is your public. .m, that is your implementation file. Okay. And anything that you put, like say here, any properties or variables that you put in the .m file, that is private to your class. Okay, so people, if they instantiate you, they will not see those, or they won't be able to have access to those. Anything that you put here that is not in the public API. Okay, good? Okay, so let's say we wanted to add some variables to our class. Now, Objective-C works on the basis of encapsulation. Okay, so it encapsulates almost all of the variables that you have except for primitives like bool, float, double, that kind of stuff. Those are primitives. But everything else it tries to encapsulate in the class. So the way that it encapsulates most things is using properties. So if I want to set a property of this class to be something like a string, what I'm going to do is I'm going to declare it here. And this is, I'm just declaring in my private, right? I'm in the .m file. So I'm going to declare something private. So I'm going to create, @property right here. I'm going to call it strong, non-atomic. I'll go over this in just a second. And then I'm going to call it NSString star, a pointer to an NS string. Okay? And the name of that I'm going to call a string. Okay? So let me go through what I just did here in this line of code. Okay, so I'm going to create a property for the demo ViewController class. It was going to be non-atomic, right, which means it is not thread safe. Okay, I can't have multiple threads trying to access this memory at the same exact time. Okay, if I declare this as atomic, then I'm going to say that's okay. And Objective-C, I want you to implement my setters and getters so that there's locking code. Okay, so that nothing just locks up. Okay, is everybody okay with that? Right? So if multiple things are trying to access memory at the same time, you manage it for me in my setters and getters. That would be atomic. Non-atomic means don't generate all that extra code because that's a lot of different checking when I don't need it to be thread safe. Okay. Strong. This has something to do with the way that everything gets allocated and deallocated. Okay. So with iOS 6. With iOS 7, it is mandatory, well, no, yeah, mostly, that things have to use ARC, automatic reference counting, okay? And what this basically does is I am saying that a string I'm making strong, and that means that I have a strong pointer to that string, which means do not deallocate the memory that's pointed to by this pointer unless I set that pointer to nil, and everybody else who has a strong pointer to that memory sets it to nil. Okay? When that happens, when there is no more references to a string right here, it's going to go inside the heap and immediately deallocate that memory. Okay? It is not garbage collection. Okay, garbage collection, you have to wait for things to come around, and the garbage collector will come by, and eventually it'll see some things that aren't there, and it'll deallocate it. No, this happens immediately. The second that the last pointer, the last strong pointer to this memory goes to nil, it's deallocated. It's gone. Okay? There's also something called weak. So if I want to have a pointer to some memory, I'm going to say as weak means that as long as somebody else has a strong pointer to this memory, don't deallocate it. But if I'm the only one that has a pointer to it, yeah, you can go ahead and just deallocate it off there. Right? That is usually we use weak for, well, so that we don't get retain or memory leaks, right? And we'll go over that probably next lecture, probably not this time. But also, usually when we're dealing with the view. So anything that we create inside the view that has an outlet, our view has a strong pointer to. Okay? So if I have a text field, the view has a strong pointer to that, and I want the view to control when that gets allocated and deallocated. Okay? So if I want to have a reference to something that's in my view, I'll declare it as weak. Almost all the time, and the default is to just have things be strong. Okay, if you used iOS before iOS 7, you also had things like retain and copy. Retain is the exact same thing as strong. Copy is almost the exact same thing as weak. Weak also says that basically if the memory that I am pointing to doesn't exist anymore, set me to nil. Okay, before when you set copy right here, you could still be pointing out into memory. It just wouldn't point to anything at all, and you could actually have runtime errors. Okay, now it sets it to nil, and you can go ahead and check and see if it's nil.
So basically, when you switch views, because the view you just switched from, it was the only one with the strong pointer to the weak properties, everything gets deallocated.
Everything gets deallocated.
Okay.
Yeah. When you switch to a view, except for some special view controllers that actually keep like the view that it came from alive, most of the time that view is gone. It is taken off of memory. It does not exist anymore for
They
you.
have to generate it again if they want to.
Yeah, and now if you click back and you want to go back to that view, everything is set up. And not only that, anything that you did in that view that was kind of customizing things is lost. It is gone. So if you were moving a slider around and you left it at 1, but it started at 0.5, you go back and you come back, bam, it's in the original presentation position. Okay? Okay, so I wanted to make sure that I go over, what did I want here? Okay. Question.
So a string, what is that?
Okay.
The string
So a string. So this is a pointer. So I also could have said this like this, right? So this is a pointer to a string, and the name of that string is a string. Okay. And notice the naming convention that I'm doing right here. Start lowercase, and then as you do new words, you uppercase the first part of that new word. Okay, and that's by convention, but it's good practice for Objective-C. Okay. Now, this is a property. So what actually is happening right here is that in the background, Objective-C is creating a setter and a getter for the backing variable to a string. Okay. Now, if I don't tell Objective-C anything else, it's just going to create those setters and getters. And the way that I tell Objective-C that I want those functions synthesized so that I have access to my backing variable is through this. And this will become a little bit clearer as I go here. I'm just going to say @synthesize, and I'm going to say a string. A string equals underscore a string. Wow. Okay, so what happens here is that when I set this property, the property's name is a string. The variable that is always going and accessing, the backing variable, is underscore a string. Okay, if you've ever programmed in C# or something, this is probably a little bit familiar with you. It's just in Objective-C, they force you to use all of this syntax. Okay, it's part of the whole thing.
So do you have to do that every time? That's synthesized for every property?
If you want the setter and getter to be created, yes.
By like automatically, like you don't have to write the getter.
You might double check me on that. but I'm pretty sure that that's the case, right? So if I do want to kind of basically overload, which is it's not really what it's doing, but if I want to specify the setter and the getter, I could say that, okay, what I'm going to do is I'm going to create this thing. I'm going to have it return an ns string star. I'm going to call it a string. Okay, now this I am implementing the getter for that property. Okay, so I'm going to do something here called lazy instantiation. So I'm going to say if not underscore a string, then underscore a string is equal to ns string with format. Don't worry, I'll go over what I'm doing here. I'm going to say this is a string. Okay, and we need to return that because we're in a getter. Yeah. Okay, so what I just did here was I said that, okay, a user is trying to access this property. It could be me. This happens maybe in ViewDidLoad. I'm going to say that if a string has not been allocated, then I'm going to set it. So if a string is equal to nil, basically, then I'm going to set it to a new instance of a string. Now what I've done here, this right here, that is a function call. Okay, really what I'm doing is sending a message, but if you've never seen this in Objective-C, it might look a little weird. This is what's called a class method. Okay. Basically what I'm doing is the ns string class, I am calling string with format in that class. And usually what you use these class methods on is when you're trying to allocate something, right? So this is going to send back to me an allocated string with this value right here, and it's going to set it into a string. Okay? Any questions on that? Not too bad. Yeah. Oh, yeah. So this @ sign here, it's just shorthand syntax for this is an ns string. Like one of the things that I also could have done here is doing string with format is nice because I could say, this is a string %d, and then I'm going to send in the number 3. Okay, and it'll format it. Okay. I also could have just done this. If I wanted to create a string here. Oh, sorry, I'll highlight that next time. I could have just saying, I want an ns string that this is a string. That's just shorthand for give me an ns string. Okay, ns, you're going to see that a lot. What that stands for is next step. It's the company that originally created an operating system on which Objective-C was based on. So you'll see things like ns string and ns data and all of that. It stands for next step, and it's just the company that created it. Apple eventually kind of bought all of the rights and that kind of thing. They started using Objective-C, so they've still got all of this kind of legacy ns stuff in it. Right? Ns object is the base object for everything, well, just about everything in iOS. Okay? Everything inherits from ns object. It allows us to do things like introspection, like is this a member of class? Or is this a kind of class type stuff? Things that we just want every object to be able to answer.
If you do it this way, then you cannot do the percentage things.
No, because I'll have to say that I want it to be a formatted string. Other question?
Yeah. What's the dash in front of the parentheses?
This?
No, where it says NSS.
Oh, yeah. So this, yeah. So I just talked about what a class method was, right? Usually the methods that we create are called instance methods. Okay, and that means that I have an instance and I'm going to send it this message. Right, so when I'm creating a function where I'm expecting some variable to be instantiated and created, I put the little minus sign there, right? So that way, and I'll show an example of that later. If I was creating a class method for demo ViewController, right? Say I wanted to create a class method, I would put a plus sign right here. I would put a plus sign, and that way a user could say, demo ViewController, give me a demo ViewController. Right, and I would allocate that and send it back out. Okay, and that would be a class method, but they wouldn't have needed an instance to a demo view controller, so they wouldn't have had to say, hey, demo view controller equals this to be able to call that method. Right? In the same way that when I did this before, right here, I didn't have to create an ns string. I just called the class ns string and said, hey, perform this method. Right? So
do you always need either a minus or a plus?
you have to have a minus or a plus.
And are variables initialized to null by default or 0?
The variables are going to be nil by default. So nil is slightly different than null. It's not really different, but so if I were to type something like this, I would say underscore string, oh come on, equals nil. That is telling Objective-C that points to nothing. Okay, it is basically that is null, but it's Objective-C type defined as this. This is a pointer, and usually it points to a class. Right now, it doesn't point to anything, which is slightly different than what null means, right? Yeah.
So if you set it to nil without affecting that reference counting strong, if you set it to nil, is it strong to say, okay, you're done using this reference,
It's going to deallocate what was in the heap. I can always allocate something else if I wanted to, right?
You say use a variable after that.
I can still use that pointer. I'll just have to allocate something else to put in it. Yeah, good questions.
Why when you're formatting string is it in brackets, square brackets?
Oh, this right here? Those square brackets are a function call. So I'm calling a function in a string, right? This will probably become a little bit clearer with the next stuff that we do too, okay? I haven't gone over that syntax with you, and I just threw it at you. I forgot about that. I'm sorry, it's my fault. Okay, yeah. So I'm just kind of like going after this. So let's just create a function really quickly. Okay, so you can see what that looks like. It's like because this is a getter, which is not really a typical function that you always write. I mean, you do write it Objective-C, but it's not just a function. So let's create another method down here. It's going to be an instance, right? So I'm going to assume that you have an instance to me. So I'm going to say void add to number. Okay, and then I'm going to say that the number that I want you is an ns number pointer my number. Okay, and we probably want to return something. Let's just return an ns number. Sorry. Okay, so let me just go over what I did. So I just created this function right here that says I'm going to pass in. So the function's name is add to number. Okay, it is an instance method on this class. It returns another ns number, right, which is just an encapsulation on some variable. Okay, ns number can store anything, as it turns out, but that's okay. But that's just an encapsulation for like float values. Normally you put float values or doubles or ints or something inside of an ns number. You just encapsulate it inside ns number so that you can put it in different parts of your code, and we'll go over that as well. But this method is going to return an ns number. It's also going to take an ns number, and the variable name is my number. Okay, I can add other things to this if I wanted to. Right. So if I wanted to create add to number with I don't know, other number, that would be an ns number pointer, and then we would say this is the second number. Something like that. Okay, so now this would actually take 2 arguments, right? And notice what I'm doing here with the naming convention of this method. Okay, I'm saying add to number this number with other number the second number that I want to add together. Okay, normally you never do this with ns number. Okay, ns number is not made for mathematic computation. It's made for encapsulation. It's just an example. Okay, don't hold that against me later on in your life. So let's just do something here. So what I want to do is return, and I want to add these two numbers together. So what I'm going to do here is I'm going to call some functions on my number to get float values. Yeah. With other number. Okay, so basically what that means is that's just a little helper right there to kind of, as you were to read this function, if someone called it, it would follow some very common sense things, right? So if I were to call this from, let's say in viewDidLoad, right? Maybe what I would do here, the way that you create an NS number is you say at, and then I could say like 3. That is an NS number. It's an encapsulated number 3, okay? So what I can do here is I can say self, right? So that is the instance that I'm calling. This is an instance method. I need an instance to call it. So I'm going to say self, which is me, the demo view controller, self add to number right here. I'm going to double click that, right? So I'm going to say add to number 3 with other number 4. Right? So add to the number 3 with the other number 4, right? And then this is kind of painfully obvious what it should return. It should return 7, okay? Encapsulated as an NS number, right? You'll notice it's not complaining that I haven't assigned this to a return value.
So did you just make that up? You made up with other number? Or,
Yes,
okay.
yes I did,
Okay.
yeah.
What do you use parentheses on NS number star in the method? Because you didn't use them when you did like the property for the NS string. Like
Oh, this right here? Yeah, this is just syntax for the method. Right, because this is the variable name, right? Or say this is the variable name right here, and this is the variable explanation, and this is the variable type. Right? With a property, all I have is a type.
So in that case, you would be calling the getter instead of just calling like the variable or something like that. Like what's the difference between NS string star and NS number star, so that you have to put parentheses in the second one?
This right here, this is just the syntax for a function, right? So because I'm declaring a property up here, right? So
that is not a function, that's a variable, right?
Yeah, it's just, I mean, if you really went down into it, like this is just, this is some shorthand syntax for creating the setters and getters in those methods. And so it knows what's there so it can create all of those setters and getters. Behind the scenes, those setters and getters are real methods that look like this, right? Like I've created right here, right? I just overloaded the the getter.
So then NS number is the getter method. It's not directly accessing the variable.
Yeah, well, it's just, it's telling that method what type this is, right? That's it. That's it. Nothing overcomplicated, right? So now if I wanted to actually implement this, I would do something like return, let's say my number. I want to get the float value for that. And I want to, I want to add that to the second number. And I want to get the float value for that. Like this, right? So I'm getting the float value for my number. I'm getting the float value for the second number. I'm adding them together. But I'm returning an NS number, not a float, right? So what that's going to do is return a float, right? So I'm just going to say, okay, and this is an NS number. And the shorthand syntax for that is at parentheses. I'm making a video of this. Don't worry, okay? I'm going to throw as much syntax as you as I can. If you've seen this before, you're really bored. If you haven't, you're like, what the hell is going on? Okay? Okay, so now, ObjectiveC is a strict superset of C. Okay? So I've got all of these ObjectiveC methods and all these properties and things that are really good with ObjectiveC. That does not mean I can't make and call C functions. So maybe I actually wanted to implement this with a C function. How would I make this function in C? Somebody, anybody. Let's say I wanted to return a float. Float, add to number,
Parentheses, and then
float,
x
call it num1, float, num2, right here. And then what am I going to do? I'm going to return, oh, come on. Really? Come on, there. Num1 plus num2, there. Yeah. Am I blowing your mind with that? Usually you don't do this, okay? You don't mix C and Objective-C code together, but it's completely plausible. You can do it, okay? The compiler's going to compile this just fine. It's going to know what to do. Question?
So what's the deal on the Objective-C part? With the, you have that, you said instances earlier with the brackets. Why do we have to wrap everything we do?
So Objective-C is built on the notion that, okay, I'm not calling functions. I'm sending a message to that instance, right? So these brackets to say, I'm going to send a message to this instance, and that message is the method that I'm sending it to. So, conceptually, that's the way that you should look at Objective-C and try to think about it. Other question?
So with respect to this course, if we could do something in either Objective-C or just normal, you would prefer the...
Do it in Objective-C. Do it in Objective-C for the most part. Okay, do everything in Objective-C. There will be some things that are super performance heavy. We need to be writing things, but when we need performance, we're usually going to do C++. Okay, and you can write Objective-C++. And a lot of the Accelerate framework that we're going to use is built on C++. We're going to use it. We're going to call C++ functions. Okay, so when you need performance, we're going to use C++. Yeah, good, happiness.
In the add number Objective-C version, do they have like auto boxing, auto unboxing that if you were to return it with the add, without the add symbol, would it auto box into an NS number?
Not that I have used. Basically, you always have to kind of designate it as, okay, and I'm returning it as an NS number. Or I could have said, return a float value there, and then done whatever I wanted to, which might have made more sense because when you're adding two things together, usually you want a primitive, right? Okay, now since I've got this string right here, let's say I went over here into viewDidLoad. I could access that by self.aString. Okay, so I can use dot notation, and that would call my getter. Okay, and if I had that in my public API, the getter in the public API, people could instantiate model ViewController and get access to a string in the same way. Okay, they could use dot notation on the class.
What about setters?
Setter's the same way. The only reason, it's just whatever side of the equal sign it's on. Mm-hmm. All right, good, happiness. You can also do things like NSArray. Right, so I could say an NSArray, my array equals, and the shorthand syntax for creating an array is @ bracket. Okay, and then I can put in an NSArray whatever I want. I can put strings, I can put other classes, I can put other arrays, I can do whatever I want in an NSArray. Okay, if you programmed in, I don't know, Python or MATLAB or something, it's just like this is just a container for a pointer. Okay, so I could put things in here like @ right? I'm going to create a string, so this is a string, right? And then I'm going to create a NS number 34, right? And then I'm going to create, I don't know, a UI label. What?
So you can mix and match in a single array.
Yes, absolutely. And not only that, I can, did I get this closed and everything? Everything's good and happiness? Okay. So if I wanted to create a for loop, I could say for ID object in my array. NS log percent at, I could say the object is equal to obj. Okay, I just did a whole bunch of things right there. All right. So, sorry, I'm just going to write it all down and then I'm going to go back over the code, okay? So what I did here is I created an array. It has a string, a number, and it has a UI label inside of it, okay? In that array, I'm going to say, okay, if this was an array of nothing but ns numbers, I could say for ns number, my number, in my array. And it would go through, and it would go through each element ordered, and it would call what I'm doing right here. Okay? Since these are all different types, I can't have everything set to an ns number, all right? At runtime, the compiler will not complain about this, but at runtime, it's going to fail. Okay, it's going to crash. So what I did is I set it to ID, which is the weakest pointer that you can have. ID can point to anything. Anything. All right, so for ID object in my array, print out to the ns log, object equals %at, which means just print whatever's in object right here. And because that inherits from ns object, it knows how to print itself. And there's all sorts of different functions and things that are there, and they've probably overloaded the print so that they know how to print themselves to screen too. NSLog is your friend, all right? That is how you get things on the command line, and you want to make sure where you are in code and that kind of things without setting breakpoints, all right? It'll just spit out to the command line, even when you're running on the phone, right? It'll spit back out to the command line, okay?
That doesn't show anything in the view, right? It's just
That will not show anything in the view. That is completely debug. Yes.
So in Android, at least, you can have like different flags for logs to only display certain level of message.
You would have to implement that on your own. It's not built in. Yep.
So on a phone, where's the log?
It'll print it. If your phone is tethered to the laptop, it'll print to the command line on Xcode. Okay? Otherwise, it just won't do jack. Good? Yeah? Happy? Good? Okay. Where else? Where was next? Okay. So let's go over here to my storyboard. First of all, let's just get rid of all of this junk, right? I just created a bunch of junk that I really don't need. Okay. Syntax basically out of the way. Yeah. Okay, so here's my demo ViewController. Let's add a button and make it change a label. That would be wonderful, wouldn't it? You can say yes. Awesome, that's what I'm talking about. Okay, so here's my button. Hey, there's a button. Here's my label. Here's my label. Okay, I'm going to say change label. Awesome. We'll just set those out right there. Good to go. Yeah, we'll do that in just a second. There's this little butler icon up here, or assistant, or whatever you want to call it. I don't know what the PC term for it anymore is. It used to be called the butler, okay? So you can click on that. Let me hide this so we have a little more view here. And now, you'll know, it automatically brought up demo ViewController, the implementation file, right? So I want to create some outlets for these things, right? So I've got these things assigned in my view right here. So what I'm going to do is I'm going to control, click on my label, and I'm going to drag it over into my code. And it's just, so it's asking me, okay, so it's going to create an outlet for this UI label. And what's it going to be called? I'm going to say my label from storyboard.
How do you open the code?
You hit the butler icon. Right? So what it did is it created this property for me, which is weak, non-atomic. The reason that it's weak is because the view holds a strong pointer to it, and we don't want to have a strong pointer to it because if we don't deallocate it, that view will never be deallocated because it's got stuff in it. Okay? So we got a weak pointer to my label from storyboard. Now, on label, I want to create an action for this, right? So our target action says, now if I drag it over here, it's going to be like I can insert an outlet or an action or whatever. If I drag it down to the implementation, it's just going to do the action for me. So if I do this, I'm going to say, okay, so for the touch-up inside event, it's a UI button. Go ahead and send me a UI button as the sender. I'm going to say change label to hello world. Why not? We have a hello world application. All right, so now what we can do here is we're going to say self.myLabel from storyboard is equal to hello world with an exclamation point, as you always do for some reason. Okay? What? Oh. The text of the label, right? So it actually gives you a pointer to the label so you can access every little thing that's in it, the color, the size, all of that. I want to change the text. Question?
How are you doing the drag and drop thing? Mine's not doing that.
Did you subclass the ViewController? So if you go over to ViewController, is it of type demo ViewController? What?
With control.
Oh, you control click or right click. It's right click. All right. Control on Mac just tells it to right click. Okay? Huh?
Because there is their right click on
Well, there didn't used to be, but now there is, basically. Okay? They decided, that's kind of useful. They started making mice with, well, they started just making trackpads. Are we on time? Oh my God, it's already 4:30? All right. Okay, wow, I'm not going fast enough. Okay, Xcode. Okay, so now what I'm going to do right here is, so it launched, change label. What? What happened? It didn't work. I didn't set up any auto layout constraints, right? So it said, oh, your size was the size of the word label. I'm not going to resize anything to you, okay? So what I'm going to go in here and do is let's just put label right here in the center. And what I'm going to do is control click, and I'm going to say, I just dragged out from it, and now I'm going to say leading space to container, okay? Or I could say center vertically in the container. What I'm going to do is leading space right here. And then I'm going to create another constraint right here, which is trailing space to container right there. I can control down, bottom space to layout. What it's done is created some constraints right here that says, keep it this distance and this distance from the side, keep it this distance from the bottom. Okay?
Wait, was that with control click?
It was control click, and you just drag, and it knows whichever direction you're going to. Okay? This is still going to be a little funky. Now I changed the label. It still did it. Why? Because it's not changing the size of the button, right? So what I want it to be able to do is I can take this constraint. Whoops. I just deleted that constraint on the right-hand side. Okay? And now let me go back over to this view. Let's bring this over. So now if I go over here, all of my stuff, the intrinsic size is default, system size. The constraint that I've added here is I'm going to have 130 points, the leading space between that and my super view. And my super view is the view of the entire controller. Bottom space right there. Okay, so now if I were to run this, voila. Okay, there's not conflicting constraints that have my size this way. Okay, it can go ahead and extend out.
How is it above change level in the demo, but below?
Oh, okay. So you've uncovered another thing. One of the constraints was that my point size from the bottom is, so many points, right? I'm running this on a 3.5-inch screen, the iPhone 4 or 4S. My storyboard is for an iPhone 5. So it maintained the constraint to the bottom. Good catch. Okay? So we'll stop that. 4:39, we've still got 10 minutes. Let's do this. Let's see what we can get done here. So I could also say that, okay, let me, run it on the Retina display. Now let's do it, which of course we want to do. And now it's going to show up a lot more like you would imagine it would. Voila. So it's there. Question?
Can you do percentage or
Not percentages per se, but you can do things like centering it vertically or centering it horizontally. Or you can say the default space, which is 8 points from the left-hand side or the right-hand side, and then it will just kind of expand to whatever it needs to be. Yeah, it's a little bit different here, but you can still basically the way to have done this would have been, hey, center it if you want it in the middle, center it in the middle, and then create maybe some kind of points for the left and the right.
Doing this type of constraining with the pixel size, would if we rotated the landscape, we pushed it out of the screen.
Absolutely. Yep. Yeah.
How
So.
do you do that?
Oh, sorry. I just command right or left, right? So I did that, and yeah, it maintained the constraint, so it's sitting somewhere up here, non-usable, right? So if you really wanted to do this right, let's go ahead and we can remove all these. What I can do is I can have it auto-generate, let's say, add missing constraints for me. And so what it did is it said, okay, this label, I'm going to center the top of it to the bottom of this button. This right here. I'm going to put some leading constraints and some bottom constraints on it right here. Those are actually in, well, I'll just delete that. I never get that to work for me when I have it auto update the stuff, so I'm just going to do it myself. Okay. I want it to center, and I want it to be vertical space in between those. Okay, let me see what this does now. Okay, it's all about defining constraints correctly. Okay, and when you do this programmatically, which we're not going to have time to get to today, but you'll want to do the same kind of constraints. Okay, good, happiness. All right. So with 8 minutes, let's create some programmatic things right here. So let's say I want to create a button, right? So we're going to create a button programmatically. I want to create a UI button, right? So I'm going to say UI button star button is equal to UI button init. Whoop. I want to allocate it, alloc. Then I want to initialize it. We're going to go ahead and init it with frame, right? So I'm going to give it a rectangle that I want it to fit into. So core graphics rect. Come on. We'll put it in the top left corner. So 0, 0, 0, 0. What are the width? The width, we're going to say it's 25 points. And the height, we'll say, is 25 points as well. Right? So it's not going to be very big. But we'll create a button. Okay? The next thing that we're going to want to do is have an action for this button. Right? So I've initialized it. I haven't added it to the view. It's just going to be a button that I've created that I have a pointer to. So probably what I want to do is I want to say, okay, button add target. Okay, so I'm going to add the target to itself, right? So this is going to be, I'm adding it to my class. The action that I want it to do is I'm going to have at selector, and maybe we'll just have this do what this button did. Okay? So I'm going to have it, I'm going to add a function here, which is change, let's just do this. Change label to hello world. And I'll go over this code in just a second. And then for control events, we're going to say UI control event state normal. Okay, so what I've done is I've added a target to this class, right? So the target, I'm going to send it over back to this class. And the selector that I'm going to perform is this, the method that I want to be called whenever the UI control state is normal. No. Don't I want this like event touchdown or something? Yeah, I want an event. There, touch up inside. We can say, we can now set all of the things on it. So button dots, what is it, title? I have to look at all my stuff here. Well, we can pause it. Button set title. We can call this is my P button. Programmatic. 4 straight, and here we go is my UI control state normal. Right, so now I've added this. Come on. There. Thanks. So it fixed it for me. Wow, it can parse what I'm doing. That's wonderful. And the next thing that we're going to do, we set the tile. I don't want to do that yet. Now I'm going to add this to the view, right? So I've got this button, I've created it, but it has nowhere to exist yet. So I'm going to say self.view, which is just something that this view controller has. This is the view that I'm in right here. Add subview, and it's going to be the button. Okay? And it's going to put it in the top left corner. It's going to be 25 by 25. We should probably make it longer. That's okay. All right. Anyway, don't worry. This init with frame we're never going to use. Okay? I'm just doing it right here so we can get something done. What? Ah. There. Forgot to close. I'm surprised I could parse anything without that. Okay. So let's play it. Where'd it go? It's not in here. Is it? Oh my goodness. Well, let's put it a little lower. What do you say? By the way, this up here is 0, 0. Okay? Wow. Why isn't it in here? Does anybody know what I did here? You know what? I'm not even sure init with frame still works, because you're not supposed to really use these anymore. Here, let's just do this. Init, like that. No, I think button dot here. Maybe this is the only way to actually do this. This might be just something that they don't want you to use. They want you to use auto layout constraints. I'm just trying to get it up on here for the thing. So let's just set the frame equal to CG rect, and then we'll do here 0.0. 0.0, 250 is the width, and the height will make 20 points. Oh, now I'm mad. What do y'all think? Is it in there and I'm just crazy? No, it should actually. So inside view did load, I create this button, and then add it in there.
So what is the UI control event touch up inside?
So that's just adding the. So this touch event, that is just for this control event.
Oh, for the button you're making.
Yeah, for that, actually just kind of perform the selector here.
So it's supposed to be called view button.
No, we always want to crawl the super first, so that it creates everything that needs to be there.
For the first one, you can do UI button space button with type. Like this example right here has a button with type colon UI button type with.
Except you have to use the system. Yeah, button. Okay. You know what? I think I actually did that.
And then it doesn't have like an allocator.
Yeah, you're right. Okay, so alloc init. You might have to use that with the slider. So you're saying, so if I were to do something like UI button, I call this on the class, and I would say button with type, and this is going to be like UI but. So rounded rec. Okay, so rounded rec is deprecated. You'll see that up here. Go ahead and use system.
For some reason, it doesn't have self.view at the end. It just has view.
There it is. I can't click on it. Oh my gosh. It's behind the status bar. Yeah, exactly. Exactly. So I could just, kind of put some wiggle room in here. Anyway, don't pay too much attention to the rounded rec stuff because we're not ever going to use it. All right, so p button. And it does the same thing. And we created it programmatically. And we are out of time. Any questions before we go? Next time, we are going to run through some UI controllers. Okay?
Does the video include like the actual photo?
Question.
Yeah. Here, let me stop the screen capture unless you want to be on candid camera here.